Good afternoon, everybody. So in the last lecture, we have to be seen the things that should be related to the comparison between types of negative feedback. See, basically, we know that there are two types of feedback, that is positive and negative feedback. So we know that positive feedback increases the gain of amplifier, but due to the positive feedback, the gain should not be stabilized. That's why we doesn't prefer the positive feedback for the case of your amplifier, right? So this is used for the application of the oscillator, that is sine wave generation. Now we have seen that uh, other type of the feedback, that is negative type of the feedback. So negative feedback is the type of the feedback which causes whatever the output gain of your transistor, that should be reduced, right? So gain should be reduced, but also that type of feedback should be preferred. The reason being, it is due to negative feedback, there should be decrease in gain, but it causes stabilizes the gain. So see, if we have applying the signal to the any devices, it should be fluctuating, means sometimes it is a 9 kilohertz, sometimes it is a 10 kilohertz, sometimes it is 11, sometimes it is 8. So it should be nothing but a variation. So it is not acceptable, right? So that's why to stabilize the gain, we have to use the negative feedback in case of your amplifier, right? See, these are the things with respect to positive feedback and negative feedback, right? We have seen that now comparative thing with respect to the different four types of negative feedback, right? So how they are differentiated? See, whatever the output of it, accordingly they have to be differentiated as a voltage. See, basically there are two types of negative feedback. One is voltage feedback, and other is current feedback. But accordingly how they have to be connected to the input part, accordingly it have two types, that is voltage series and voltage shunt, current series and current shunt. That are the types of your amplifier, right? So in that case, we have discussing the whatever the parameter and whatever their effect. So see, that are the revised part, but I may explain again. See, first thing, parameter, that is gain. See, in case of any of the amplifier, either your voltage series, voltage shunt, or current series or current shunt, all of the amplifier, if we have to be applied, causes the gain of amplifier, that should be reduced, right? So reduces indicate that is not acceptable. See, but see, this is acceptable with respect to the negative feedback. The reason behind it is, when we have to be applying the negative feedback in case of your amplifier, in that case it causes whatever the gain, that should be stabilized. That's why if we have applying the any type of the, that is voltage series or voltage shunt or current series or current shunt, it causes there must be reducing the gain of the amplifier, but it stabilize the gain. So this will be happen in case with respect to the gain of amplifier, right? Then we have seen the second parameter, that is bandwidth. Bandwidth is nothing but operating area of the particular amplifier. What it indicates, that operating frequency of amplifier. So normally audio frequency indicate that start up with the 20 hertz to the 20 kilohertz, right? That frequency is called as audio frequency range. So during that frequency, means if we are applying the signal in case of your voltage series feedback, so it causes, consider that your operating frequency is 20 hertz to the 20 kilohertz. But if we have to be use the voltage series type of feedback, in that case, whatever the bandwidth, that should be, if needed, see, if needed, it should be exceed about the 20 kilohertz, right? This should be happen in case of your voltage series feedback, if we have to be used. The second is voltage shunt type of feedback. Voltage shunt type of feedback, when we have to be used and apply the signal, that is audio signal, it also causes whatever the gain, that should whatever the bandwidth, means operating frequency, that also increases. This will be happen all the, means either your voltage series, voltage shunt, or current series or current shunt, all the cases bandwidth, means operating frequency of your amplifier increases, right? So see, third thing is noise, means we have discussing that point, means parameter point with respect to the what we have applied the signal to different type of the amplifier, right? So if the what means, when we are applying the signal, means negative feedback amplifier signal to the different amplifier, and noise is coming with respect to, right? So when we have applying the voltage series feedback, in that case, whatever the noise is nothing but a unwanted signal. So unwanted signal is coming with respect to your voltage series feedback, that should be reduced in case of we have think with respect to the noise. Same thing will be happen with respect to voltage shunt, current series, and current shunt type of feedback, right? So see, when we are applying the signal to the particular type of the amplifier, any type of amplifier, it causes noise should be reduces all of the type of the negative feedback amplifier with respect to voltage or current, right? Distortion, what do you mean by distortion? That I'm telling you. See, if we have transfer the signal to the one part to the another part, right, in that case, if we have transfer the A, whatever the signal going other, that is another, right? म्हणजे ए जर पाठवलं तुम्ही असेल तर तिथं दुसरंच काय बी किंवा सी किंवा अदर काय गेलं असेल तर तुमची सिग्नल डिस्टॉर्टेड म्हणजे चेंजेस किंवा डिस्टॉर्ट झालेली असते. लक्षात घ्या, डिस्टॉर्शन म्हणजे काय असतं? इट इज नथिंग बट ऍडिंग नॉइज. Due to adding noise, there should be elimination of certain part of the signal. This is nothing but a distortion. So when we have to be discussing the distortion point with respect to all type of the either your voltage series or voltage shunt or current series or current shunt, it causes your distortion should be decreases, right? When we have applying the negative feedback signal, then input impedance. See, any of the devices, one of the critical thing with respect to amplifier, it must have highest input impedance, it must have lowest output impedance. Why that? See, input impedance high, it indicate that if we have applied the signal and any noise is coming with respect to that input, that noises are eliminated. When it is eliminated, when the input impedance is more, right? And output impedance indicate that when output is impedance less, it is the less acceptable. Why? Because output impedance less indicate that any of the device should be connected to the output of your devices, right? So with respect to input impedance, in case of voltage series feedback, as the input impedance is increases, this is acceptable, right? In case of voltage series feedback, so it is positive thing. In case of voltage and feedback, it is decreases. So when it is decreases, means noise added with respect to this type of the amplifier, right? So see, current series feedback, it causes input impedance increases, right? Input impedance increases indicate that noise is not added with it. When we're discussing with respect to the current shunt feedback, it causes input impedance should be decreases. So decreases indicate that noise should be added with respect to it, right? So see, output impedance, what it indicate that, so with respect to output impedance, it must be less, right? So it must be less. See, only with respect to your voltage series and voltage shunt feedback that have less input impedance, and the other, that is current series and current shunt feedback, have the high input impedance. So what happen? It is for the connection purposes to the device, such as it must be connected to the loudspeaker, any of the loudspeaker, right? So that have requirement, if the it is more value, it require the large value of the loudspeaker, right? So when the output impedance less, that causes any of the device should be connected to it less resistance, right? This will be the thing with respect to the comparison of the different amplifier. See, ideal characteristic we have seen. So see, there are three parameters with respect to your amplifier. One is input impedance, output impedance, and the gain, right? So in case of voltage amplifier, gain should be infinity. In case of current amplifier, gain should be 0. In case of transconductance amplifier, gain should be infinity. In trans resistance amplifier, it is a 0, right? So see, with respect to our RO is nothing but output resistance. For the voltage amplifier, RO should be 0, means output impedance should be 0. For current amplifier, it is infinite. For the transconductance amplifier, it is infinite, but trans resistance amplifier, it is a 0, right? Why it indicates? See, when we have to be use the different application of your amplifier, in that case, how it is prepared? This will be seen by this Ri and Ro. See, Ri is, we must require, see, we must require Ri should be more, right? Ri should be more. So Ri more indicate what? It have higher impedance, so noise is not added. So in that case, we should prepare the voltage amplifier and the transconductance amplifier, right? So RO, it should be less, either your 0 or 5, 6 ohm, right? So in case of your voltage amplifier and in case of your transconductance amplifier, it is a near about 0. See, it is ideal value, it might be 4 or 5 ohm, right? So in case of application of these two more preferred, voltage amplifier and the transconductance amplifier, which we have requirement of the less output impedance. Okay, now we have to be how the find of the gain of these four configurations. See, voltage amplifier indicate that it whatever the input voltage, it is nothing but a Vs. Vs is the input voltage applied across your amplifier into gain of that amplifier. It is nothing but a. So your V0 output is nothing but a gain into Vs input signal applied. So V0 is equal to gain into gain factor is nothing but a gain factor into input voltage applied. For current amplifier, it is a current amplifier. It is nothing but IL. For that, current gain into applied input current. So AI into IS. For transconductance amplifier, see, for transconductance amplifier, it is a GM into, it is not seen here, GM into whatever the voltage applied. GM is nothing but a transconductance applied across it. So for that purposes, transconductance means applied input, sorry, applied output is nothing but a, tell you same thing. See here, Im equal to Gm into Vs, right? This is nothing but a what value of the load current. In that case, Gm is nothing but a 1 upon R. 1 upon R is nothing but a transconductance, right? So 1 upon R is conductor considered as a Gm. So for that transconductance amplifier, IL equal to Gm into Vs. Vs is nothing but applied voltage, right? So applied voltage into the transconduct, that is nothing but a IL, means current of that output, right? So see, trans resistance type of the amplifier, it is nothing but a V0 equal to resistance R into applied current IS, right? This is the thing with respect to the gain of the particular configuration. In case of trans resistance, it is a V0 is equal to R into IS. IS is nothing but applied input current. Okay, this is the thing. These are the revision part. Now we have to be seen that the important part, that is advantages of negative feedback. See, we have seen that there are different way to use negative feedback for the application, right? We have seen that one of the application, that is amplifier. In that application, we have to be used, it should reduces the gain. I'm again tell you, but it stabilize the gain. This will be happen, right? So see, first point, highly stabilized again. We know that when we have to be use the negative feedback, it causes gain should be reduces, but reduced again indicate that it must be stabilized. Okay, stabilized indicate that it doesn't changes with respect to your operating frequency, right? Now see, improved frequency response. Now, improved frequency response is what? When we have to be operating the your amplifier with respect to 20 Hz to the 20 kilohertz, right? It is the operating area of the your amplifier, right? But what happens sometimes, it is not operated in that particular scale, right? Why? Because it must be fluctuating, means changing, right? So changing indicate that it should be sometimes 11, 9, 10, that will be happen. But if we have to be use the negative feedback, in that case, that should not be changing. So what it indicate that your whatever the frequency, that should be improved, means does not changes. This will be happen. Then distortion in amplifier are reduced. So see, why the distortion are coming in case of your amplifier? Why? डिस्टॉर्शन म्हणजे काय? अनवॉन्टेड सिग्नल त्याच्याशी आल्यामुळे. लक्षात घ्या. तर इथं आपण in case of this type of the negative feedback amplifier, we have to be use the negative feedback. Due to negative feedback, and another thing, we must use the input impedance maximum, right? Input impedance maximum indicate that noise addच होणार नाही, right? Noise add झाला नाही म्हणल्यानंतर तुमच्यात डिस्टॉर्शन क्रिएटच होणार नाही. So that in case of negative feedback, there should not be distortion, that should be reduced if it is, right? So operating point is stabilizer. Now see what do you mean by operating point. ऑपरेटिंग पॉईंट म्हणजे काय असतं, ज्यावेळेस आपण ट्रान्झिस्टर एखादा ऑपरेट करायला लागला तर त्याला मिनिमम अमाऊंटचा करंट आणि व्होल्टेज जर अप्लाय केला ना, त्या पॉइंटला म्हणतात मिनिमम ऑपरेटिंग पॉईंट. लक्षात घ्या. तर ज्यावेळेस आपण एखादा ट्रान्झिस्टर आहे किंवा एखादा डिव्हाइस आहे, त्या डिव्हाइसला आपण मिनिमम अमाऊंट त्याच्या बायसिंगसाठी व्होल्टेज अप्लाय केलं ना, त्याला रिक्वायर्ड असणार, तर त्याला म्हटलं जातं ऑपरेटिंग पॉईंट. राईट. तर याचा ऑपरेटिंग पॉईंट म्हणजे नॉर्मल ऑपरेटिंग पॉईंट हा स्टॅबिलायझर राहतो, कारण की आपण निगेटिव्ह फीडबॅक यूज केलेला असतो त्यामुळे. ओके. दीज आर द सम ऑफ द ऍडव्हांटेजेस ऑफ युअर निगेटिव्ह फीडबॅक. ओके. नाउ सीन द डिसएडव्हांटेजेस ऑफ निगेटिव्ह फीडबॅक. राईट. सी जगामध्ये नो वन इन द वर्ल्ड आर परफेक्ट. राईट. आपण म्हटलं की पॉझिटिव्ह निगेटिव्ह फीडबॅक आहेत काय ऍडव्हांटेजेस, काही त्याला डिसएडव्हांटेजेस सुद्धा असणार आहेत. लक्षात घ्या. So when we have to be use the negative feedback, it causes whatever the impedance with respect to it, it should be increases, means either your input as well as output impedance. Right. This will happen. So in case of current shunt and current series, it should be means both thing, that is your input impedance and output impedance that should be increases. लक्षात घ्या. म्हणजे जर इनपुट इम्पिडन्स इन्क्रीज झाला, लक्षात घ्या, तर त्याचा काही इफेक्ट होत नाही. पण जर तुमचा आउटपुट इम्पिडन्स इन्क्रीज झाला तर त्याचा इफेक्ट होतो. जर तुम्ही निगेटिव्ह फीडबॅक यूज केला ना, तर त्याला काय होणार आहे की तुमचा आउटपुट इम्पिडन्स वाढणार आहे. लक्षात घ्या. कोणत्या ह्याचा, करंट शंट असेल किंवा करंट सिरीज अँप्लिफायर असेल. लक्षात घ्या त्यांचा. त्यामुळे काय होतं, जर आउटपुट इम्पिडन्स वाढला तर तुम्ही व्हॉट एव्हर द डिव्हाइस कनेक्टेड अक्रॉस इट्स आउटपुट that have more or less in it have requirement of the less resistance. It is not easy. Right. त्यामुळं आपण जर तिथं निगेटिव्ह फीडबॅक यूज केला या दोन्हीसाठी, म्हणजे कोणत्या करंट शंट आणि करंट सिरीजसाठी, तर त्यामुळे त्याच्या आउटपुट इम्पिडन्सवर परिणाम होतो. लक्षात घ्या. वाढतो. increase in output resistance, that I am already told you. Reduction in input resistance in a case of voltage shunt and current shunt type of the amplifier. Right. See, any of the device I am already told you, input resistance should be more. Why it is more? Tell me. Any of the device which should be worked as amplifier, it must have requirement of the impedance that should be higher. Why it is? किती तर वेळा मी सांगितलेलं आहे, सांगा. प्लीज टेल मी.
When the input impedance is high, then their noise can't
enter in the amplifier. Right. And with respect to output impedance, it should be less or more. See, with respect to output impedance, it is a less or more required. See, we have requirement of the higher input impedance and less input impedance, because higher causes no noise is added with it, and when lower it indicate that any of the device should be connected to the amplifier. Right. So see, this is the thing. So now seen that more number of amplifier stages are required in order to obtain the required gain. What it indicate? See, मी तुम्हाला सांगितलं, मला एक्झाम्पल सांगतो. ज्या वेळेस तुम्ही एका क्लासरूम मध्ये बोलत असाल, लक्षात घ्या, क्लासरूम मध्ये बोलत असाल, क्लासरूम थोडा मोठा असेल, लक्षात घ्या, तर समोरून जे पॅसेजवरून तुमचे टीचर बोलत असतील ते सगळ्यांना ऐकू जाणार नाही. राईट. त्यावेळेस तिथं काय केलं असं, समजा एखादा माईक विथ ऑडिओ अम्प्लिफायर यूज केलेला असं समजा, त्यामुळे काय होईल की तुमच्या पूर्ण क्लासमध्ये तेवढा तुमचा आवाज, म्हणजे जो तुमचे टीचर आहे त्यांचा आवाज जाईल. बरोबर. पण समजा तोच मला, म्हणजे तो एरिया जो आहे ना, तो क्लासरूम ऐवजी फक्त एरिया जर समजा मोठा एखादा मैदान असेल तेवढा करायचा असेल, तर त्या केसला तुम्हाला तो सेम अम्प्लिफायर चालेल का?
No, sir.
Right. The reason behind it is we have requirement of the more gain, म्हणजे जो एरिया कव्हर करायचा ना, that must be more. Right. For that purposes we have requirement of the different stage of the amplifier. Right. एक स्टेज जर यूज केली तर आवाजाची क्वालिटी कमी असेल, तर मग एकच्या पुढे 2, 3, 4 किती एरिया वाढतायत त्यानुसार तुम्हाला तेवढे स्टेज ऍड करावे लागतील. स्टेज ऍड करतो म्हणजे काय करतो आपण, तेवढं त्याची गेन वाढवतो, म्हणजे तेवढी त्याची स्ट्रेंथ वाढवत राहतो. लक्षात घ्या. म्हणजेच मोर अँड मोर नंबर ऑफ स्टेज आपल्याला ऍड करावे लागतील. ओके. ऍप्लिकेशन ऑफ निगेटिव्ह फीडबॅक. इन ऑल इलेक्ट्रॉनिक अँप्लिफायर. लक्षात घ्या, आता मी तुम्हाला सांगितलं अँप्लिफायर मध्ये मस्ट यूजच करावा लागतो निगेटिव्ह फीडबॅक. जर तो नाही यूज केला तर अँप्लिफायरला नॉईज क्रिएट होते किंवा त्याचा रिस्पॉन्स हा चेंज होतो, म्हणजे तो अँप्लिफायर वर्क होऊ शकत नाहीये. लक्षात घ्या. त्यानंतर रेग्युलेटेड पॉवर सप्लाय, म्हणजे पॉवर सप्लाय तुम्हाला माहित असेल लॅबोरेटरीमध्ये यूज केलेला पॉवर सप्लाय, त्याच्यामध्ये याचा यूज होतो. म्हणजे तिथं कशासाठी यूज होतो सांगतो. आलेली सिग्नल जे आहे ना ती पुढे जाताना त्याच्यामध्ये गेन मध्ये चेंज होऊ नये यासाठी तो रेग्युलेटेड पॉवर सप्लाय मध्ये यूज केला जातो. कारण फ्लक्च्युएशन रेग्युलेटेड पॉवर सप्लाय त्याच्या नावामध्येच आहे. आपण पहिल्या चॅप्टर अनरेग्युलेटेड पॉवर सप्लाय, ऍक्च्युली अनरेग्युलेटेड पॉवर सप्लाय मध्ये फ्लक्च्युएशन झाले तर पुढे जाऊन आपण रेग्युलेटिंग थिंग यूज केलं तर 78XX किंवा 79XX. पण इन केस ऑफ ऍक्च्युअल रेग्युलेटेड पॉवर सप्लाय मध्ये काय असणार आहे की इनपुट मध्ये काय पण चेंज होऊ द्या, आउटपुट मध्ये जे व्होल्टेज आहे ना ते फिक्स राहायला पाहिजे. लक्षात घ्या, त्या केसमध्ये ते फिक्स राहण्यासाठी इथं यूज केला जातो. ओके, हे लक्षात आलंय का? ऍडव्हान्टेजेस अँड डिसएडव्हान्टेजेस ऑफ निगेटिव्ह फीडबॅक. प्लीज रिप्लाय द्या. आलंय लक्षात? प्लीज रिप्लाय द्या. पुढे जायचं. बचोटे लक्षात आलंय? देवबारे लक्षात आलंय का? हॅलो, रिप्लाय द्या.
Yes, sir.
Okay. See, we have seen that whatever the effect of input resistance, म्हणजे इनपुट रेजिस्टन्सचा इनपुट रेजिस्टन्स वर तुमचे जे पर्टिक्युलर अँप्लिफायर आहेत ना, व्होल्टेज सिरीज असेल किंवा व्होल्टेज शंट असेल किंवा करंट सिरीज असेल किंवा करंट शंट असेल, त्याच्यावर तो किती पट वाढतो लक्षात घ्या. यासाठी आपण एक इक्वेशन डिराईव्ह करणार, म्हणजेच काय इफेक्ट ऑफ इनपुट रेजिस्टन्स. इनपुट रेजिस्टन्सचा इफेक्ट तुमच्या आउटपुटवर किती होतो, त्याच्यामुळे तुमचा किती पट आउटपुट रेजिस्टन्स वाढतो ते आपण याच्यावरनं पाहणार आहोत. लक्षात घ्या. ओके, इक्वेशन फॉर दॅट. सी, वी हॅव सीन दॅट दिस इज द ऍक्च्युअली diagram, circuit diagram configuration of the voltage series feedback amplifier, right? So see, in that diagram, see, we have applying the input signal applied for that voltage series feedback, that is Vs input signal. When Vs signal is input signal is applied to this configuration, in that case current flowing through this configuration, it is called as II current. At that time when we have applied the Vs as the input voltage, in that case voltage flowing through the device, it is a Vi, and current flowing through it is II through the resistance Ri, right? This will be related to the input as well as the voltage, means feedback voltage, as the feedback voltage applied across it that should be again coming to the input, that is a Vf, right? Whatever the value of Vf, it is nothing but a current gain into output, right? So value of Vf, it is nothing but a current gain of it beta, and applied output is V0, right? So whatever the thing coming with respect to your Vf, that is nothing but a feedback, it is nothing but a current gain into V0. Current gain is nothing but a beta, V0 is nothing but output, right? So to calculate the particular value, we have to be applying the KVL with respect to the input. See, input, this is input loop, this is output loop, right? So when we have applying the KVL to the input side, start up with the first point, right? See, applying KVL to the input loop, right? We have start up with this Vs, so it is a positive Vs, right? Then going towards the here, right? So that's why Vs going towards the Ri, so it is nothing but a Vs plus minus, so it is nothing but a Vs minus of Ri, current flowing through the it is a II, so Vs minus of Ri into II, and going towards the here, right? So plus minus, so minus Vf, right? So your equation is Vs minus of Ri into II minus of Vf, right? This is the equation with respect to your input, right? Vs minus of Ri minus Vf, which is equal to 0. Now we have taking this as with respect to the Vs, right? So that Vs equal to, so Vs equal to Ri II plus Vf. Why it is plus? Because term which are here going on other side. So Vs equal to Ri into Ii plus Vf. This will be the coming, right? But for the Vf, they have already given Vf is nothing but a feedback is nothing but a phi0 into beta, right? Vf which is equal to beta into phi0. So for the Vf, we have to be written as a beta into phi0. Vf beta into phi0, right? So Vs equal to Ri plus Vf. Vf is nothing but a beta into phi0. Beta into phi0. This is nothing but equation 1. तर इथपर्यंत हे सगळं लक्षात आलंय का मला सांगा आधी, त्यानंतर आपण पुढे जाऊ. कुठलं टर्म किंवा काय कसं आलंय लक्षात आलंय का? प्लीज रिप्लाय द्या.
येस सर.
ओके. हे जे इक्वेशन आहे ना, यातलं हे जे सांगितलं तुम्ही डायरेक्ट डायग्राम काढली. डायरेक्ट डायग्राम नाही ऍक्च्युली. ज्यावेळेस आपण व्होल्टेज सिरीज फीडबॅक तिथं पाहिलाय आपण कुठं ब्लॉक डायग्रामच्या फॉर्मॅट. तो ब्लॉक डायग्रामच्या फॉर्मॅट मध्ये आपण पाहिला तो आणि इथं वेगळं असतं. कसं असतं वेगळा? हा ऍक्च्युली सर्किट डायग्राम आहे, लक्षात घ्या. त्यामुळे हा सर्किट डायग्रामच्या फॉर्म मध्ये आहे. त्याच्यावरनं आपण हे जे इक्वेशन काढलं Vs इक्वल टू Ri into Ii plus beta into V0. This is nothing but equation number 1. Okay. Now see whatever the equation coming for Vs, it is Ri plus beta into V0. Now, but we know that output voltage, finding the output voltage with respect to this, right? Output voltage आपल्याला याच्या रिस्पेक्ट टू जर आपल्याला पाहायचं असेल V0, तर कसं करणार आहे? इथं आपल्याला व्होल्टेज डिवायडर रूल अप्लाय करावा लागेल, राईट? इथं जर व्होल्टेज डिवायडर रूल अप्लाय करावा लागला तर त्या केसमध्ये आपण काय करणार पहा. इथं जर व्होल्टेज डिवायडर रूल अप्लाय केला तर काय असणार? हा रेजिस्टन्स प्लस डिवायडेड बाय या दोन्हीचे ऍडिशन ना अप्लाइड व्होल्टेज असं असणार आहे. परत येतं सांगतो, जर मला याच्यासाठी म्हणजे आउटपुटच्या साठी जर मला याचं सांगतो तुम्हाला, आउटपुट व्होल्टेज जर आपल्याला काढायचं असेल, पहा आउटपुट व्होल्टेज जर आपल्याला याचं काढायचं असेल तर इथं आपल्याला केव्हीएल सॉरी व्होल्टेज डिवायडर रूल अप्लाय करावा लागेल. व्होल्टेज डिवायडर रूल इथं जर अप्लाय करायचं असेल तर काय असणार आहे? हे दोन रेजिस्टन्सचं रिलेशन असणार आहे, लक्षात घ्या. तर काय असणार आहे? हा रेजिस्टन्स डिवायडेड बाय हे दोन्ही रेजिस्टन्स इंटू मल्टिप्लाय बाय इनपुट voltage applied, right? So RL divided by RL plus R0 into AV into VI. This is nothing but a voltage divider rule as we have applied. See, V0 equal to RL divided by R0 plus RL into AV into VI, right? This is nothing but a VDR. VDR is nothing but a voltage divider rule, right? So see, in case of 1 minute, 1 minute. See, we have discussing the voltage divider rule applied. So it is nothing but a V0 equal to RL divided by R0 plus RL into applied voltage AV into VI, right? So we know that when we are discussing with respect to the voltage series feedback, we know that for voltage series feedback आपण पाहिलेला आहे. voltage series feedback साठी आपला जो R0 आहे, सांगतो. व्होल्टेज सिरीज जो फीडबॅक असेल ना त्याच्यासाठी तुमचा जो व्हॅल्यू आहे R0 ची ती 0 असते. पहा व्होल्टेज सिरीज त्याला ट्रान्स रेजिस्टन्स अँप्लिफायर असं म्हटलं जातं. 0 आहे पहा इथं, त्यामुळे ती व्हॅल्यू 0 असते. पहा द आउटपुट व्होल्टेज इज गिवन बाय V0 इक्वल टू RL बाय R0 प्लस RL इंटू AV इंटू VI. हे झालं. त्याच्या पुढे आपण R0 ची व्हॅल्यू 0 असते कोणासाठी? व्होल्टेज अँप्लिफायर. म्हणजेच तुमचा जो अँप्लिफायर आहे, कोणता अँप्लिफायर? हा अँप्लिफायर जो यूज केलाय व्होल्टेज सिरीज फीडबॅक अँप्लिफायर. लक्षात घ्या, व्होल्टेज सिरीज टाइपचा अँप्लिफायर असतो, त्याला व्होल्टेज अँप्लिफायर असं सुद्धा म्हटलं जातं. सी मी सांगताना मग उलट झालं पाहिजे ना, 1 मिनिट. व्होल्टेज अँप्लिफायर असतो, लक्षात घ्या. व्होल्टेज सिरीज अँप्लिफायर म्हणजे व्होल्टेज अँप्लिफायर असतो, लक्षात घ्या. व्होल्टेज अँप्लिफायरचा R0 हा 0 असतो, लक्षात घ्या. 0 असतो व्हॅल्यू. त्यामुळे पहा इथं काय करायचं,